Subscribe to LearnCap and hit the bell icon to get notified.
Regression analysis, as noted to you. It's a second part for correlation regression, whatever we discussed in the last lecture. Correlation. Now this is the second part, which is called regression. So basically what is happening, guys, we'll start with the lecture. In the correlation, what we discuss. So correlation gives us the small r, that is the relation between your bivariate data, that is x and y, bivariate data, that is x and y. So correlation gives us the r, that is the relation between two variable x and y, which is termed as a bivariate data. Now after this understanding of correlation, that is a bivariate data, and understanding the correlation between them, the relation between x and y, we'll use that concept in the regression. So basically what is happening here, I'll tell you. Suppose you have two variable again for the regression. Suppose you have two variable x and y again. So x may represent your advertisement, and y is representing your sales. So there is a conditional relation, like for example, the advertisement is always been done to promote the sales. So suppose you have advertisement, and suppose we have sales, this is x and this is y. So you are doing advertisement of 50,000 and the sales in return is 2 lakhs. And then the relation goes on, like suppose we increase on our 10k, it becomes 60k, the sales will become 2.35 lakhs. Likewise, we have 70, 80, 90. We can keep on increasing 10,000, because to the other side we are seeing the advertisement is increasing. Like it becomes 6.5, this becomes 3.07, here it becomes 3.25. So more we are doing the advertisement, the sales goes on increasing. So in correlation, we understand the relation between x and y. So here we understand the correlation. No, it's k means the 1000. K stands for 50,000. So k is 1000. L is lakhs. That's a rupees. 50,000 is written as 50k. 60,000 written as 60k. It's not constant. So we understand the advertisement and sales relationship by correlation. Now in the regression, what we'll do, suppose we want to know on a 1 lakh or 1.5 lakh, 1 lakh or 1.25 lakh advertisement, how much will be the sales? Or we'll say ki if we want a sales of 5 lakh, how much advertisement we have to do, how much costing advertisement we have to do. So that means we are talking about estimation. We are talking about estimation. So we'll understand estimation between the two variable after understanding the correlation. So once you understand the correlation, now you can in a position be doing estimation of maybe x over y, or maybe y over x. If you know x, you can estimate y. If you know y, you can estimate x, but only when you have the relationship, the correlation between x and y, then only you can do that. So this is the lesson all about. Regression is identifying or estimating the value of one variable when the other is given to you. Then how we are going to do all these things, how we are going to estimate all these things. So we'll make a function. We'll make a function, because that function will easily give you the estimation. it will easily give you the estimation. So we'll go for a function. So see the definition in the regression, what it says. Regression analysis says it is a statistical method which is helping us to formulate a functional relationship. So we'll be creating a function something like this, y is f of x. So the equation you can say, or the function you can say. So it is a functional relationship between two variables, that is x and y, in the form of algebraic equation. So obviously this functional relation will be into the form of algebraic equation. So that equation can be a1x b1y plus c1 equals to 0, something like this. So algebraic equation, yes boy, the linear equation, the linear equation. So the statistical method, regression analysis, is a functional relationship and is in the form of an algebraic equation which is helping us to estimate the value of one variable when the other value is given to you. So it can be either of the way, that x will be given, you estimate y, or y will be given, that will estimate x. Means we are not going according to the data analysis, we are going according to the functional relation. So it is a scientific method, functional relation, in the form of an algebraic equation, and we use that equation for the estimation. That's what is regression analysis. In one word, we can say regression is all about estimated values. To find estimated values, we use regression. Okay, so from the foundation point of view, we'll understand the method, how the method has been developed to find out the estimated values. Okay, is it clear guys with the definition ki we are making a functional relation? This is one point, in the form of an algebraic equation, and then we are estimating the value of one variable where the other value is be definitely given to you. Now see, we'll create some points for you, like for example, estimating y on x. Suppose you are finding y when x is given, or you are estimating x when y is given, either of the thing, both the cases we'll see. What first thing we have to do? We have to find out the averages, arithmetic mean between x and y. Arithmetic mean average is sigma x upon n, and arithmetic mean y is sigma y upon n. That is what? Ki total of x by n, you will get an average of x. So what is x? Suppose for example the advertisement we are taken as an example, and y we are taken sales as an example. So what is the average advertisement? That is x bar. What is the average sales? That is y bar. So first thing we have to do is what? To take the arithmetic mean. And as I told you, it's a functional relation. It is converted into a linear equation. And I want to tell you one thing over here. So this linear equation, that is a1 x plus b1y plus c1 is equal to 0. It is a linear equation. It's a linear equation of two variable, which is a line. Basically, it is representing as a straight line. So, matlab, this functional relation, the equation is graphically saying is a line. So, if it is a line, and we are forming a line, if we are forming an equation, we are forming a line, that means definitely we are supposed to find the slope also. Every line has a slope. And then the second point is what? We'll go for regression coefficient, that is nothing but, I'll tell you, this is nothing but a slope for a line. And the first slope is y on x, that is y depends on x. If x will change, the y will change. So byx is the slope of y. So in the last lecture we did covariance of xy. You have to divide it by variance of x for getting the regression coefficient, that is the slope of y on x. And to get the slope on x y, again the same thing, you divide covariance of xy and upon variance of y. So this, when you know x and you are finding y, and this is when you know y and you are finding x. So we are slowly going for a formation of a line. Like for example, we are forming that particular equation, and for that particular equation, first we made a arithmetic mean, second we made a slope. And slope we did it by covariance, and we have many formulas in the slope. It's not only one formula. This also we can write as a formula when we expand the covariance. This is from the last lecture, you have to see the last video. Covariance xy is sigma x minus x bar, y minus y bar, and variance of x is sigma x minus x bar the whole square. Covariance of xy, again the same thing, and the variance of y is sigma y minus y the whole square. So this is one formula, but this formula is specifically applied when you know your x and y bar is integer. See, your x bar is integer, your y bar is integer. Means every time you have to do x minus x bar, and it is possibly when your x bar is integer, the complete value, then only you can do it very fast. Otherwise, if it is a decimal value, you can't do it very fast, and then it will take a time. Exam will not ask you to do the entire sum like this, but everything, each and everything in and out you should know. So I am showing you all the formulas relatedly. If it is not integer, if it is not a complete number, if it is a decimal, you can have a second formula also, which is n sigma xy minus sigma x into sigma y. See the difference between these two. Here the difference is taken only once. Here the difference is taken every time with the x. So suppose there are 10 times x. We deduct that x bar from that x 10 times. And here we do the difference only once. So if it is a decimal also, doing difference one time is possible. But doing difference 10 times is not possible. So this is used when it is non-integer x bar, and this is used when it is a integer. So there are two main classifications of the formula. And what is the basic theme for the formula? Covariance of xy upon variance x, covariance of xy upon variance 5. So you can see though both the things parallelly, estimated y on x and x on y. One more formula I have, R is what? The correlation regression between x and y. So it is R standard deviation of y upon standard deviation of x, and R standard deviation of x upon y. So there are altogether 4 ways to find out the slope. There are altogether, how many ways are to find out slope? 4 ways. Once you get slope, then we can form a line. So which line we are forming? Maybe you know this, y minus y bar is m x minus x1, x minus x1. This is we are doing in the school. The general form, teacher says the general form is ax plus by plus c is equal to 0. And we write that in one more form, y minus y1 is equal to mx minus x1. This is called slope point form. Why it is called slope point form? Because when we know the slope and when we know one point, we use this. So y minus y1 is equal to mx minus x1. Now see, y minus y1. What is y1 and x1 in the case of regression? So it is x bar and y bar. Means what? When two lines meet each other, the point of intersection is x comma y. But when two regression lines meet each other, the point of intersection is x bar and y bar. So the point here in the regression is x bar and y bar when two regression lines are meeting to each other. Okay, why I am talking about line? Because I already told you regression is the functional relationship which is expressed algebraically in the linear line form. So this line, what we did in the school or in the colleges, we are using the same line here for the regression, and the y1 here will be y bar. Slope is byx if it is y on x, and x minus it will be x bar. So the same thing is written in the regression like this. See, this is written for your college sessions. This is written as your college session. This I can say your school, and CFC we are writing like this. So the same line converted into a regression. and we will use this line for the estimation. So I have this in the slide further. Regression line. Finally, the line has been made, and y minus y bar is equal to byx x minus x bar. Whereas in the other case, the point is x minus x bar, bxy, y minus y bar. Once the line is formed, then you are able to substitute the value of x in this. You will definitely get y. Substitute the value of y, you will get x. So see, the entire method will go into the flash back, and we'll try to recollect the entire points. See guys, what is regression here? Regression is the statistical method, and it is creating a function relation. How it is creating a function relation? By algebraic equation. Which algebraic equation? Linear equation in two variable, and estimate the value of one variable with the help of other. So it is used for estimation. A preparation of line will go. First we'll find the point of intersection of two regression line. That is by finding out the averages x bar, y bar. Then we'll find the slope. Slope is written as byx or bxy, covariance of x upon variance of x, covariance of xy upon variance of y, and the different form of these slopes. You can see the different form of slopes. Then the line is formed. These are the two lines. These are the two lines here. First line, second line, and then after this substitution. So the institute will not ask you the entire thing like write so much of things. No, they will either ask you the point of intersection of regression line. So we'll answer on this. Maybe they will ask you only slope. Okay, fine, we'll do this. Maybe they will ask you only line. I will do this. Maybe they will ask you find out y when your line is given to you, like that. Matlab, they will ask you the question in parts. They will not ask you the entire question. Okay, so this is what all about regression. Further certain properties are there, but we'll go for the MCQs first, whatever we discuss, and then we'll come to this. Okay, what I'm talking about, suppose the line is now y minus y1 is equal to mx minus x1. Why I'm telling you again and again, because this is a learning process, and we converted now this line into y minus y bar is equal to byx x minus x bar, like this. So this is your normal line, this is your normal line, and this is your regression line. So we have further after doing some MCQs we'll discuss, we have slope related properties, the slope of the line related properties, and we have the properties related to the entire line also. So the two more concept will be that properties of your regression slope, this one, and the property of the entire line. It's the entire line. That's it. Although the chapter is very small, first to understand what is regression and how to calculate regression analysis. And second thing, the main thing is all about line of the regression. So you'll be learning slope properties as well as the line properties. Okay. See, the first MCQ, whatever we discuss up till now, it's based on it. Regression analysis is concerned with what? What it is concerned with? Establishing a mathematical relationship between two variables. Is it creating some mathematical relation between two variables? I must say yes, it is creating a mathematical relation between two variables. Measuring the extent of association between two variables. Okay, it measures the it is measuring the association, means the relation between two variables. No, the relation between two variables is done by the correlation. So it is not working for the relation of the two variables, it is working for the estimation. Okay, and C is what? Predicting the value of dependent variable, means to find dependent variable when we know independent. Yes, this sounds good. Prediction is the part of regression. So A is correct. It is making a relationship between two variable, mathematical relation, and prediction is correct. That means the answer D is correct. I must say you are convinced with the option. Regression analysis is concerned with what? Functional relationship, that is mathematical form, and prediction, that is called estimation. We'll go for the next. If there are two variable x and y, then the number of regression equation could be. If two variable, there will be two equation. One is what? Y on x, other is what? X on y. So the answer is 2. Okay, fine. Next we'll go for, since the blood pressure of the body of a person depends on the age, the blood pressure is depend on age. As the age goes on increasing, the blood pressure rate also goes on increasing. It is normal in the beginning, and as the age goes on increasing, the blood pressure also goes on increasing. So what kind of equation you are going to form? Regression equation blood pressure on age, or regression equation age on blood pressure, or the both. Okay, so we'll say it is regression equation blood pressure on age. So blood pressure is depend on age, so we'll find blood pressure on age equation. Okay, suppose if it is something else like dependent on independent, you always remember this, it can be dependent on independent. Okay, so dependent is blood pressure and independent is the age. Now see the next one. The method applied for deriving the regression equation is known as. Now this is out of box, but we can use the option elimination. Concurrent deviation, no, it's not, because it is there. It is the method of correlation. Product moment, Carl Pearson product moment. If you there in the last lecture, you might know Carl Pearson product moment correlation coefficient. It is again the method of correlation. Normal equations, no, normal equations are used in regression, but in the main context, we use the least square method. We use the least square method. Least square. The answer is least square. So you might be wondering here how from where the context of least square comes. I must show you this. We have to go back some slides before. See, I skipped this. I had skipped this in the theory. Least square method of regression. So I had skipped this theory in the box. Least square method, y on x and x on y. So this is the main method where we finding a regression first, and then it comes to the method which we had discussed. But this method is not that used in the calculation. Okay, so least square method comes out of this context box. It is included in the theory. Fine. Students, what I am saying you, the least square method is one of the part which have not been discussed yet in the slide. So it is out of context. The question we can learn it theoretically like this. Concurrent is not there. Product moment is not there because that is from correlation. Normal equation is used for regression formation, but the main method is the least square method. Okay, we'll go further. The difference between the observed value and the estimated value in the regression analysis is known as. Okay, so that value is known as error. It can be error, it can be residual. Okay, it can be error also, it can be residual also, and that is what A or B. Now you have to listen it very carefully. This is again a new part for you, and I will take you back. Okay, fine, chalo, I will take you back to the exact theory course, because after this the more sum will come on the properties as well as on more theoretical basis, and you need more theory backup. So we'll go back after completing our regression analysis ka type. Will discuss certain properties on the slope. See, here we ended up the theory and we've done the 4 MCQs there. We'll go for the regression coefficient. Coefficient is what? The slope of the line. We're talking about slope of the line property. The regression coefficient measures the change in dependent variable corresponding to an unit change in the independent variable, that is byx and bxy. Byx is y changes according to x, and bxy is x changes according to y. See, byx change in y with respect to x, bxy, change in x with respect to y. So this is the first point. What is the slope all about? These two terms. Second, when I multiply this byx and bxy, we got r square. And what is r square? R square mein r is what? The coefficient correlation. Okay. And when we take the square root on both sides, see, when we take square root on the both side, we got plus minus under root of byx into bxy. Means r can also be calculated by using the correlation coefficient. What we did in the correlation. The correlation and now regression. So if you know the regression slope, you can find the correlation. So it is by formula r is equal to plus minus under root of byx into bxy. Okay, so the straightaway point says, if you know your regression line slope, you can find the correlation between x and y, that is small r. How it is possible? R is equal to plus minus under root of byx into bxy. But concerned, what to take plus or minus, or when to take plus and when to take minus. So if your regression coefficients are positive, r will be positive. If they are negative, r will be negative. They will not go in the opposite direction. Either both will be positive, either both will be negative. That depends on. So r positive, negative totally depends on regression coefficient. So here I had given the byx and bxy are either positive or negative. It cannot be opposite. Consider r positive if regression's coefficients are positive, or vice versa. Okay, so 2 points in this slide, it explaining you what is slope, change in y with x or change in x with y, and how to find the small r, the correlation r, by using coefficient regressions. So it is under root of byx bxy. We go for third one. That means what? If this is coming under root of byx and bxy, isn't it a geometric mean? Because it is an average of two slopes. See, byx and bxy, it is a byx and bxy. So it is an average of byx and bxy. That means r is what? R is the geometric mean of byx and bxy. This is also a wonderful clean point which you should remember. So the slope is a geometric mean between the regression coefficient. This correlation r is a geometric mean GM of regression coefficient. Regression coefficient means byx and bxy. Fourth will go, if one is greater, if byx one is greater, the other has to be less than 1. So if one is greater than 1, other has to be less than 1. Why is it so? Because we had learned that whenever I calculate r, the correlation coefficient, the previous part, it is always coming between -1 and 1. So r ka value is always between -1 and 1. It never shoot 1 or -1. So for that reason, one byx is greater than 1, the other has to be less than 1. Then only you will get the correct answer. Otherwise, you will not get the correct answer. Means your r will not be correct. If both are greater than 1, they are not correct. If both are less than 1, okay, fine, that is fine. If both are less than 1, means the r will be coming in between -1 and 1. But if both are, if one is greater than 1, the other has to be less than 1. Okay, this is third property. Fourth is average of byx and bxy upon 2. If I take byx and bxy upon 2, it is always greater than or equal to r. So the regression coefficient average is greater than the correlation coefficient. byx and bxy are independent of origin. Means if you change the origin, what is origin change? If you do something plus in the data, or if you do something minus in the data to reduce the number. Okay, usually we don't do plus, you do minus only. To reduce the data, we use that minus, change of origin, and that doesn't change the value, that doesn't change the meaning of byx bxy, but it is dependent of change in scale. The scale means if you do multiplication or division. I'll give you an example on this. Suppose your x ka value is 10, 8, 6, 12, okay, these 4 elements. So suppose if I do x minus 8, x minus 8, at 8 is what the one number among this only. So 10 minus 8, the first number will be 2, 8 minus 8 will be 0, 6 minus 8 will be minus 2, 12 minus 8 will be 4. See, the number is reduced in such an extent, 10 becomes 2, 8 becomes 0, 6 becomes minus 2, 12 becomes 4. That means what? The data is reduced, and the data is reduced is called change in origin, but it doesn't affect the answer. You can do it anytime. But if you change the scale, like for example, your x is 10, 20, 30, 40, 50. What you do? Divide your data by 10. If it will become 1, 2, 3, 4, 5. So the data is reduced to such an extent by scale. But the scale will affect the answer. Origin will not affect the answer. By doing minus in the data will not affect the answer. Anytime you have x and y, you do some minus in that answer, you change the data accordingly, the answer will not change in the origin, but in scale it will change. So suppose we consider h is the change in x we made and k is the change in y we made as per scale, not as per origin, because origin doesn't affect only the scale is affecting. So your relation will be formed as b by x, the original answer will be k by h into bvu. That is your k what? Change in y variable upon h is what? Change in x variable into whatever your new answer, that is bvu. You take that also, and if you put up this relation, your new answer will come into the actual answer, that is b by x. And in case of bxy, you do the opposite ratio, h upon k into buv. Means if you want to bring your answer, into the normal xy after doing the change in scale, you have to multiply the ratio k upon h, and here it is h upon k. What is h? Change in x, and what is k? Change in y. So if it is only origin, guys, see, if it is only origin, I'm not talking about scale, then your byx and bvu are same. No need to do anything over here. After doing origin change, the answer will remain same what we are getting in xy and what we are getting in uv. But in the scale, you have to do this relation and convert your answer back into xy. Okay, so these are only 4 properties or 5 properties we have for the slope. Just have a look on this again so that you will get it. See, what is the first one? What does exactly the regression coefficient slope means? There are 2 slope. One means y change, x change, y change. Means x is changing because y is changed. So it is change of y with respect to x, and this is change of x with respect to y. Both are related with the correlation. So r is plus minus under root of b by x. But in this case, if both are positive, r will be positive. If both are negative, r will be negative. And the r becomes by the time the geometric mean for both. If one is greater than 1, other has to be less than 1. The average is always greater than or equal to r. And the origin doesn't affect, but the scale will affect. Properties of line. Means the entire line we are talking about now. See, first of all, 2 lines regression. One is what? Y on x. Other is what? X on y. So y on x, x on y, 2 lines are there. If they intersect, the line intersect and the intersection point is x bar, y bar. I told you before also. Acute angle. If you want to find out the acute angle between 2 lines, the formulas are this: tan theta. Now you said the trigonometry is completely banned out of trigonometry, the CA foundation, but somewhere we can use it. Tan theta is byx bxy minus 1 upon byx bxy. Okay, this is not necessary formula. I just put it on the extra note, but the first one is important. Tan theta, product of the slope, regression slope, the product of the slope. See this, the product of the slope minus 1 and divided by sum of the slope. Okay, now some behavior of the line, how the line behaves, like if r is 0, if the correlation coefficient is 0, the regression lines are perpendicular, means your y on x line and x and y line, both are perpendicular to each other. If your r is 0, if your correlation is 0. But if your correlation is exactly +1 or -1, the regression lines will be identical. They will coincide on one another. So if your R is plus minus same, they will coincide, and if R is 0, the lines will be perpendicular to each other. Okay, so these are very intelligent points, and then you don't have to go graphically. You have to just remember this point. When your correlation is R, the regressions are perpendicular, the lines are perpendicular. When your R is perfect 1 or -1, the lines will coincide. Now see, this is where we come back from the MCQs. A regression line Y on X kya karta hai? What it do? Y on X line minimize the vertical error, and X on Y minimize the horizontal error. Now I'll tell you this here. Suppose this is your graph, and these are all bivariate data, the scattered points, and you made a line. Okay, the estimated line. Now see, Y on X is doing what? It's minimizing the vertical error. So it is minimizing this error, because all lines are scattered. The lines are not go in the same path. So it will minimize, see, it will minimize the vertical distance. And what X on Y will do? X and Y will minimize the horizontal distance. Means all the points will try to come towards the line. So all these points here will try to come towards the line, because we are forming a function based on the line. We are making a regression function on a line, but all bivariate points are scattered. So the function will be designed like that. Y minus what you did, Y minus Y bar, is what you want to bring all these points which are scattered vertically and horizontally. So the vertically minimizing is called Y on X, and the horizontal minimizing is called X on Y. Okay, this is also the point, very important, from where we come back from the MCQs. Yeah, in 90-degree format. In 90-degree format, in 90 degree. See, this point is there. It will try to minimize perpendicular like this, and this point is also coming the straight. This angle is created, so we can't say exactly 90, but I am talking on the basis of when you did Y minus Y bar, you use this in the line. Hello. When you use this in the line, Y minus Y bar and X minus X bar. So you try to bring all the points very closer to. So we can't say 90, will say in a straight way, in a vertical manner or in a horizontal manner. Yeah, horizontal or vertical. The angle doesn't count here. Angle doesn't count here, because if you say angle, the angle is not making 90 there. The difference between the observed value and the estimated value is called error. Okay, now observed value and estimated value, again the same diagram we need. See, this is the observed value. These points are the observed value, and the line is what? The estimated value. This is the estimated value. We make line for the estimation. So the difference between this and this is the error. Exact error is this. Okay, whatever error left is. So the difference between the observed value is the scatter diagram point, and the estimated values are the points on the line. That is called error. And if R increase numerically from 0 to 1, if your R start increasing, what I told, when R is 0, the lines are perpendicular, right? When R is 0, the lines are perpendicular, and when R is +1, they are coinciding. But if R increases from 0 to 1, now the angle will start diminishing from 90 to 0 degree. See, if R is 0, the angle is 90 degree. If R is 1, the angle is 0 degree. But if your R start increasing, your angle 90 degree will diminish to 0 degree. So if the R changes from 0 to 1, the angle also comes down from 90 to 0 degree. Okay, this is one point. Other points are we can cover it in the MCQ, because this point theoretically it is not so important. How to identify the line, like they will give you two lines. How to identify X on Y line and Y on X line. How to identify which line is Y on X and which line is X on Y. So I use this condition, modulus A1 B2 less than modulus A2 B1. If this satisfy, if this condition satisfy, it directly says the first line is Y on X and the second line is X on Y. If this condition is satisfied, if it doesn't satisfy, then vice versa. Then the first line is X on Y and the second line is Y on X. Okay, so these are the points we done. We'll go back again and we'll see what points we done. Two regression line, the point of intersection is X bar Y bar. Acute angle formula, this formula is important. R0, the lines are perpendicular. R1, the line will coincide. Y on X minimize the vertical distance, X on Y minimize the horizontal distance. Difference between the observed value and estimated value is residual. If R increase from 0 to 1, the angle diminish from 90 to 0. And if two regression lines are there, which one is Y on X? The condition should satisfy A1 B2 less than B2 A1. And the least square method will drop, will not discuss. We'll go for our MCQ which we left behind. See this one. Now you are more capable of answering. The difference between the observed value and estimated value in the regression analysis is known as the error also. We can say that is error also, residual also, D. Yeah, it's D. Okay, it can be error also, it can be residual also. The error in case of regression equations are, how the error can be? It can be positive, it can be negative, it can be 0 also. If the point, observed point is coming on the regression line itself, then the error is 0. Yeah, it is all the three. It can be the positive error also, it can be the negative error also, it can be no error, that is 0 error also. The regression line Y on X is derived by, how Y on X is derived? By minimizing the vertical distance. See, the minimization of vertical distance, yes. So the answer is A. The two regression line become identical. When they become identical, same to same, when R is 1 or minus 1. When the R is plus 1 or minus 1, they are identical. They will coincide. The answer is A or B. Okay. So the properties will help you to solve the MCQs more properly. What are the limit of two regression coefficients? What are the limits? Should I say no limit? Should I say must be positive? Should I say one positive, other negative? Should I say the product of regression coefficient must be numerically less than unity? Yeah, this is the correct one. Means BYX and BXY. Okay, the product should be less than 1, because when I say it is less than 1, my R will be between minus 1 and plus 1. There is a restriction, the product should not go more than 1. See, what is the formula we learn? We learn the formula R is under root of BYX and BXY. If the product of regression coefficient, if this product is more than 1, suppose this product is 2, what will happen? R will come 1.41, which is not possible. So the product of this two has to be always less than 1, so that your R will come between that range of minus 1 and 1. So the answer is D. Your R should be always between minus and 1 and 1. That's the reason I told you, if your BYX is greater than 1, the other has to be, BXY has to be less than 1. So suppose this is 3, it's fine. This is 3, it is fine. No issue, absolutely no issue. Then your other one has to be less than 1. Other one has to be less than 1. So it should be something 0.1 suppose. Okay, so the product of both 3 and 0.1 will be what? 0.3. And the under root of 0.3 will obviously come in the -1 and 1 range, which is good for R, like it is satisfying the condition of R. Okay, and here come the last MCQ here for today's session, that is 10. So you have to go through the theory properly, all that theory. It has been nicely explained by me in the videos also very slowly. In the 1 hour session, it is very less time actually saying to explain the entire concept more of if possible. So the regression coefficient remain unchanged. When it remain unchanged, regression is not affecting, by origin it is not affecting, or by scale it is not affecting. It is by origin. It is by origin it is not affecting. If I change the origin, it is not affecting. If I change the scale, it will affect. So the answer is origin change. Okay. So I hope students you like this entire session. It's a very short session of 1 hour. And but we had covered the entire concept of regression, and I hope you got sorry, 10th one. The 10th one, the answer is shift of origin. Origin change will not affect the regression coefficient. Scale change will affect, but origin change will not affect. We covered this in the theory here. I'll go back and show you immediately. Here. You can see. Check here. See this point. Byx and bxy are independent of origin, means it is not affected by origin, but it is dependent, means it will affected by scale. Got it? Okay, chalo, nice talking to you, boy, and we'll winding up this session. Thank you very much.
Subscribe to LearnCap and hit the bell icon to get notified.